I am tremendously grateful for the fact that I won the birth lottery. So it turns out it was actually a cultural thing. Um, the way in which you had to stand to pump the water was not decorous for a woman wearing Indian clothes. Circumstances have helped or hindered, and in the end, brought us to where we are. And that it's a long journey. There are lots of successes, but there are also like real challenges along the way. I did not want to be changed by the culture of the discipline. I wanted to continue to be me.
Welcome to the Indianness Podcast, a show about leaders of Indian origin who have overcome challenges and worked with dedication to ultimately achieve success. By telling the stories of the defining milestones in their journeys, we hope to inspire others to learn how they too can succeed in their pursuits. Here's your host, Sanjay Puri.
Welcome to the Indianness Podcast, stories of changemakers of Indian origin. Why have Indians achieved success across so many different disciplines around the globe? I keep getting asked that question all the time. I have no idea, but let's find out together. I'm absolutely thrilled to have Professor Natarajan with us today. She's the Futon Professor of Astronomy and Professor of Physics at Yale University, where she also serves as Chair of the Astronomy Department. Priya has literally mapped the invisible universe, creating the first detailed maps of dark matter and pioneering our understanding of how supermassive black holes formed in the early universe. She was also named as one of Time magazine's 100 most influential people in 2024, and this January became the first Yale faculty member to win the prestigious Denny Heinemann Prize for Astrophysics. But what makes her story so fascinating to me is her journey from a curious child in Coimbatore and Delhi who was mesmerized by maps to becoming one of the world's leading voices in understanding our cosmic origins. Welcome, Priya. It's an absolute honor to have you on our podcast.
Thank you, Sanjay ji. It's a real delight to be able to have this conversation with you. Thanks for the invitation.
Wonderful. Priya, we have a global audience, and obviously, the podcast is Indianness. So here we really try to figure out the journeys of change makers like you. What were the inflection points? What were the influences? So that folks who are listening can use it as a learning moment, an inspirational moment, and also just get to know you a little bit better. So tell them a little bit about your journeys. I mean, when I say journey, really go right to the beginning. Where were you born? And tell us a little bit about your childhood.
Yeah. So I think, first of all, I am tremendously grateful for the fact that I won the birth lottery. So I say that because, the accident of birth really shapes a lot that happens. And I was born to two absolutely wonderful parents who were academics. And I was born in Coimbatore, which is where my mother's family is from. But then we moved rapidly to Chennai and then to Delhi, which, and my father was a extremely well-known educationist who transformed the educational landscape in India. And so I had an academic household. My mother is a sociologist, and she was interested in trying to understand nomadic tribes. And so I grew up in a middle class family, well off enough to have lots of books around, lots of intellectual stimulation around, and most importantly, a family milieu where my parents encouraged each and every interest of mine. And I felt very indulged. And also, because of the kind of intellectual life that they led, the life of the mind, there were people in and out of my home, all kinds of vice chancellors, scientists, thinkers, artists, musicians. And we were in Delhi, we were South Indians in Delhi. So almost anyone from Chennai, whom my sort of larger, how Indian families are, we're kind of networked, friends of friends, and third cousin, fifth cousin, etc. Anyone would come to Delhi, they would come and stay with us. And so I got to just meet amazing people. And I think, you don't think about these things when you're a child, right? So these things sort of, role model for you that especially a lot of people who were doing very creative, innovative, new things in different fields, right? And in their own way, some of them were very famous. The former President Abdul Kalam was a part of this thing. Professor Yashpal was part of my family's milieu. They were all my uncles, and I sort of knew them. And you don't
Mhm.
realize as a child that just being around these people who are incredibly accomplished and yet humble uh, is a sort of very active kind of role modeling. It's not that I felt I wanted to become like this or that. I was forging my own way, but all of these people kind of, encouraged me as a child. So that's why I keep saying, I won the sort of birth lottery. So then I went to school. I was always curious. I was always reading a lot across fields. I had very broad interests, and in a home where there was both sort of science and engineering as well as the arts and humanities with my mother and social sciences. What was encouraged was, at dinner table conversations, we all had to be really, I have two younger brothers. And so we were all encouraged to read, learn, ask, and be curious. And I remember like an obsession with cartography and maps. And in fact, my parents had an old, they had these films, these little films that you could show in a projector. They had one of me where it's probably 3 years old, trying to pick up the Times Atlas of the World, which I obviously couldn't pick up, but attempting to do that and opening pages. And I loved maps, and maps of the earth and maps of the sky. But then when I was young, my parents actually bought me because I was very curious. And by the way, when I say curious, it's not a euphemism for naughty. I was not naughty. I was a really good girl, very well disciplined child, but really curious. So they bought me a telescope and a microscope just to see what I would do with it, right? What did I want to play with, right? And it was the telescope for me. And I think there was something, when I think back about what it was, I think the fact that you could never quite touch anything in the sky, no matter how far you reached. The fact that you couldn't manipulate that, right? That was part of the mystery and seduction for me. Whereas, with the microscope, right, you could make the plates. So, I had all the plates. I would take various plants, leaves, insects, and kind of look at them. And so, yeah, it started there. And, again, my father, because he was, and my mother were academics, they would go for conferences abroad. This was all when India, the economy was closed, right? So this was in the 70s and 80s when I was growing up. My father got me a Sinclair ZX Spectrum. So I had a computer at home to play with before anybody I knew in India had one. So I learned how to program, and I was started making, predictably, sky maps on that. And then I had a very important mentor that really sort of shaped a lot of, once again, at the time, I didn't realize how much it shaped my thinking and my decision. She gave me a first taste of research. So I was part of the Amateur Astronomers Club in Delhi at Nehru Planetarium. And they had a new director, Dr. Nirupma Raghavan. Sadly, she's not around anymore. But I pestered her, and so I would go very regularly, and I offered to help and volunteer. I was still in school, and I finally told her, I want to do something. I have a computer. I can help you with some calculation. I have no idea what. And I pestered her so much that she finally said, you know what? Let me give you a problem. Go and do it, and then we'll see. And so she gave me a very hard problem, as it turns out. And so she asked me, what are you interested in? I said, math. She said, okay, there's a column in Indian newspapers to this day where there's a night sky published once a month, what all planets you could see, when you could see them, which are the bright stars, and so on. So there's a star map. And so she said, oh, this is great. So why don't you draw the star, make up a star map for Delhi? And I said, okay. And it's very hard because I did not know spherical trigonometry at that time. I was still in 10th grade. But I knew trigonometry. I just didn't know spherical trigonometry. I knew calculus. And so I set about working on this. I spent the entire summer. She thought she had gotten me off her back, and that's it. It's a hard problem. This kid's probably not going to come back. But I did it, and I went back and I showed, this was before we had laptops, right? So I had a printout with that print paper, dot matrix print paper in which I had printed out maps for a couple of months, and I showed it to her. So first she didn't believe I had done it. So I had to take her through how I'd done it and how I'd learned spherical trigonometry, spherical geometry. And so then she was like, to test me, she said, oh, well, very presciently, she said, this is great, Priya, but what if you were living in Boston suddenly? What about the night sky then? Right. I said, oh, no worries. I have written the program in such a way that you can put the latitude and longitude of any place on Earth, and I could make you the star map. And so at that point, she later told me that's when she realized, okay, here is a kid that I would have wanted to have as my kid to help them. And from then on, right, she really encouraged me. I was doing calculations for her. So she was a solar physicist. She worked on sunspots. So I did some calculations for her, and I got a taste for research. I got, there's this, the thing about research is that there's this wonderful feeling of joy when you figure something out. Even if you're not the first person to figure it out, you're not making a discovery, but somebody's done it already, but you do it your own way. That feeling of excitement and contentment, I can't tell you, that joy is unparalleled. And I discovered that joy very young, very fortunately, and I'm hooked on that moment. But it's also frustrating, right? Because every time you're trying to do research, you don't know the answers. A lot of the times, you don't even know how to frame the question. That's part of the process, right? And so I think, and it can be very frustrating for a lot of people who are really impatient, and I've seen that coming through as a student, that that frustration, for me, that frustration is kind of exciting. It kind of motivating. And so, yeah. And then again, as I said, right, I was fortunate. I realized that I wanted to take courses in the humanities as well. I didn't want to go to IIT and become an engineer, wanted to do physics. And I also didn't want to study in India because, you're tracked very early. So in an undergraduate curriculum in India, if you do Bachelor of Science in Physics, perhaps you take a course in mathematics or two, maybe one in chemistry, but that's it. You don't read any history. You don't, there are no courses, taught courses. And I didn't want that. I wanted, a much broader. And then the only option, I also wanted to do research as an undergraduate because now I was hooked, right? And I actually found out that MIT had an undergraduate research opportunities program. It was one of the first institutions to actually have that. They had it in the 80s. And so I applied to there, and I applied to the top schools, not because I knew they were top schools, but I applied to those five places because they gave financial aid, right? So my parents obviously could not afford it, and also the Indian economy was closed. So I was lucky, got admitted everywhere, chose to go to MIT. And so, you talked about in the intro about these inflection points, right? And I think for me, there are these moments, I call them like very specific, launch moments. When you look back, when they're happening, you kind of know it's an incredible opportunity and that you're really grateful for it. But you don't understand in the long arc how pivotal all of those things are. I mean, I knew that MIT was going to change my life. I absolutely knew that. Little girl, I was quite young when I came. A little girl coming all the way. At that time, it was very unusual to have undergraduates because we had to be fully supported on scholarships to come. And MIT was the perfect place for me then because, I had this kind of curiosity, brimming with curiosity, and it was the perfect place to explore. And then I had another inflection moment. I had a lot of, there was a lot of guilt after enormous success at MIT and multiple degrees and all of that. I felt I need to do something socially useful and important. So I had this like little kind of flirtation with technology and public policy with appropriate technology. And so I went to India to a rural institute, the Gandhigram Rural Institute, which is now a university. And I did a project. I won a prize to go do a project because I said I want to understand how technology and science interface with the public in a day to day, and not just kind of elite technology, but we're talking basic things to give you the basics for life. So at that time, the World Bank had spent a lot of money setting up these water pumps in villages in India. And the report was that they were not used, and I thought that was an intriguing problem. And I said, okay, let me go and figure out. And I thought it would be a science and engineering problem, right? I thought maybe there's, with my physics, I could do something, right? So it turns out it was actually a cultural thing. Um, the way in which you had to stand to pump the water was not decorous for a woman wearing Indian clothes. You had to keep one foot well above the other with your feet really apart in a way that, it just, a woman wearing a sari would never do that in public. And so that's why it was not being used. So I figured that out like in 10 minutes, and that's when I realized that, science and technology really need to be attuned to the culture and the people who are going to be using it. So one size fits all, and something that's discovered in America might work for this context, but for India we need something else. We need the technology, but it needs to be modified, tailored, and honed to the needs of the people. So I did that project, and then I realized that, having an impact in that field, there's just too much politics, and that I did not have a taste for. And you have to deal with bureaucrats and kind of people pushing back on things that were actually good for the larger good. So I realized that, I probably better off just doing physics, and that I felt a lot that I didn't feel after those explorations that I was being so utterly selfish, because felt very selfish to be doing physics, which I loved. And when I had to do something, I also come from a family with a long history of public service, so that's part of it, that I felt I had to give back in some way. So I went through all those torture things. And then I was also very interested in history and philosophy of science. So I had a little bit of a flirtation with that. I started another PhD. And then everything changed because I was, for that PhD, I was doing, you have to write a prospectus of what you're going to do and you have to defend it. So I took all the courses in the humanities. It was also at MIT in a program called Program in Science, Technology, and Society. And part of that, I was going to look at simulations, computer simulations, and how in fields like cosmology and astronomy, where you can't do any controlled experiments, right? They serve as proxies for experiments. And so they told me, like, part of this, it's a history and philosophy program. So you have to write one chapter on the history of computation. That means the Manhattan Project. That's where everything started in America for computation in any field, right? And so there was one surviving astronomer at Princeton who had retired. His name was Martin Schwarzschild, who knew von Neumann and had worked with all the people on the Manhattan Project. So I went to interview him, and that was another inflection point. And he said, "Why aren't you doing physics when you say you love physics?" I said, "Oh, I have a plan. I'm going to do this, then I'm going to do a physics PhD." And I said, truthfully, I was a little stuck finding a problem that I didn't want to do string theory at the time, didn't want to do particle physics, because the Large Hadron Collider had not been built, and so there was like a desert in terms of data. So he said, well, I said, I love ideas, and I like, kind of connecting disparate things and building a storyline and making predictions that can be tested, validated, and proved right or wrong. And he said, I know the guy you should work with. You need to go to Cambridge, England, and work with Martin Rees. So that, put me. So these little encounters, and it's people, it was people that I chanced into, that I ran into in my life, that kind of gave it this sort of, these arcs curvature to make me move. And then I went to Cambridge, and I had a slightly personal rocky start. I was very briefly married, wrong person, wrong time, everything, too young, shouldn't have. And that broke apart. It was very traumatic for me. And that was sort of the first time I hit some kind of real obstacle in my life. And but then, I just completely focused on my academics. I got over it. My parents helped me tremendously through that. I was always one of these people when I was young, where my intellectual growth was way ahead of my emotional growth, because you have to live life to grow and learn and fail and learn. And so then things really took off. Cambridge, and I was elected a fellow of Trinity College, where I was a student before I finished my PhD, which is like a rare honor. And it also is a pathway to a future job in Cambridge, which I didn't want. I wanted to come back to America, which that was home for me. But that's another that launched me. You know how these points launch you into a different trajectory somehow. And I think that was really pivotal for me. And I think I'm particularly grateful to Trinity College, Cambridge. I have a real fondness because of how they supported me as a human being, because of what I had to offer intellectually. I didn't have to prove myself ever to them. They already respected me from the day I entered. And when I had this sort of personal setback, they were there. Like to this day, I don't know who paid my rent for 4 months. When I just left Cambridge, I was so upset when things went bad personally. I went home to Delhi. I think it was my advisor, or it might have been my college. Nobody will tell me that, but I didn't have to worry about anything. That kind of kindness and that kind of support, you I'm sorry to say that it's not something you will get in America even today. And so I'm very grateful for these systems of education that I ended up in, where I needed, when I needed a very empathetic kind of place. I was lucky I ended up there. Then I came to America, and what I needed was, competitive motivation to push my intellectual limits. And then I was ready for that. When I was ready for that, I got that. And so then I came to Yale. I got a job without any postdocs. It's completely short circuited the route to a faculty position. And I've been there since. I've risen through the ranks. Yes, there have been lots of challenges. I think academics at this level, if you want to play, it's very competitive and has a lot of challenges. And I don't think I have to say this on the Indianness podcast, but we all know that when you are Indian, you look like us, you speak like us, no matter what chops you have in terms of, MIT, Cambridge, whatever. It's not the same. We have more obstacles, right? And I think things are changing. They've been changing. Some things have changed fast. Some things have changed slow. So anyway, this is a very long answer to your first question on, but I just want. I know I've heard some of the people that you've talked to before, and I think I love the fact, Sanjay, that you like hone in on the fact that all of us have some inflection points where things could have gone like completely differently, but they went in a particular way. Obviously, the combination of our own self determination and all that, and grit and resilience, but that circumstances have helped or hindered, and in the end, brought us to where we are, and that it's a long journey. There are lots of successes, but there are also like real challenges along the way. And I think I've learned almost as much from the challenges as I learned from the successes. Um,
Great. That's a incredible journey. Lots of learning. So let me see if we can just break it down very simply for our audience, because as I said, there's a lot to be learned here. So I'm just going to again, for our audience, one of the things you obviously said, you hit the genetic lottery, the birth lottery, or whatever you want to call it. Uh, but you also said something which has been brought up. I mean, we try to basically synthesize what are the commonalities of change makers like you. That there were a lot of people that would come in with diverse backgrounds in the house. Yes, there was Professor Abdul Kalam, Yashpal, etc. But let's keep those names because everybody's home doesn't have those things. But but you have diverse viewpoints. How did that, just briefly, did that help you? Forget that they were, leaders or whatever else. How did that help you? Because if people who are bringing up kids, there are a lot of people who listen here and say, hey, what are the best formulas to bring up kids? How did that help you?
Yeah, I think, as you rightly put it, right? I mean, these names are only part of the galaxy. Just to emphasize the a point about
Mhm.
my birth lottery, I learned from everybody who came to our family, right? There were lots of young people that my parents helped launch careers, get jobs in Delhi, and so on, who stayed with us. I learned a lot from those people too, because I engaged, with them as well. I think one of the things I got from everyone, including, our Mali, who worked in the
Mhm.
gardens. My parents were obsessed with their garden, beautiful garden,
Mhm.
and I am obsessed with plants as a result. Like, it's about mastery. What I learned from everyone is that it's about mastery and dedication. No matter what you do, this idea that you have to master it, you have to understand it at a great depth, you have to figure out, the goal is to go deeper and deeper, and not to get quickly content with surface level understanding, that you have to go deeper and deeper. And I learned this
Mhm.
from, as I said, like the people who would otherwise be seen as humble, who were helping us too in the household. We had people coming to help us, and I would see that each one really knew their job very, very well. And
Mhm.
I would talk to them, and they would tell me that, yes, it's about, the depth of understanding. And I got that same message from everybody, like the humble people from very humble origins who were doing, not so prestigious things, as well as the really prestigious people I ran into in my life, right? It's always
Mhm.
about mastery, and I think I got tuned to that. And in terms of, as you said, for parents who are bringing up their children, I think there is a way in which we tend to not understand that the depth of the foundation, at least in the academic realm, right? It's knowledge.
Mhm.
It's having really good grasp of mathematics. In my case, I'm talking very specific. I'm not saying this is what everybody should have, but real
Mhm.
grasp, like foundationally strong grasp of mathematics and physics. And that's not just feeling okay, I took an exam, I aced it, that's it, I know it. It was never enough for me. I mean, the acing an exam was like an incidental thing, which, the key thing was, anytime I was given a problem, I was working on a problem for a problem, homework, exam, whatever is, can I do it a bunch of different ways, the same problem? Can I arrive at an answer, bunch of different? It was my personal challenge. The teacher didn't necessarily want us to do that, but I always set that as a personal challenge, because I was like, I would understand very different things and at different levels, different approaches, right, to the same problem. And that is something I actually cultivated. And I had that once again because, I had some mentors. I had a fantastic mathematics and physics teacher in high school. I was in Delhi Public School, Arkipuram. And it's before it became this large kind of industrial conglomerate, right? There were just a couple of schools, and I had the most fantastic physics and maths teachers. They knew, for example, that I had mastered the material that was needed for CBSE for those exams. Well, so very quietly, they would give me, extra problems to do and take the time to talk to me. And, I'd tell him, oh, I figured this out. Does it work like this? How else could I do it? So again, I was, as I had that luck, but as you say, I also had the interest, right? I would put in the effort. I think when we have achieved a lot, everything seems really easy. Although in research, you never quite coast, you never reach there because you're constantly trying to break frontiers, come up with new discoveries, you're pushing yourself, you're pushing your intellectual limits all the time, right? But
Mhm.
the idea that you want to understand something really deeply, I think it sets you apart as a scientist. I think there are a lot of scientists colleagues that I have who are excellent, who have great minds, but I think they get a little satisfied a little too early compared
Mhm.
to someone like me. It's relentless, right? And one could call it slightly obsessive, but I mean, you've probably heard this from many of your guests, that there's a sort of a healthy level of obsession that people do have for their passions that they develop.
Yeah. A certain level of passion, certain level of obsession, a great deal of curiosity is what you are saying. Uh, at the end, I do want to talk to you about the whole DPS, Columbus, modern school rivalry, but we'll get to that at the end towards that. But so let's talk about some of the inflection points you have kind of raised and see, because those are also great learning moments. You got a telescope that was kind of an inflection point. And correct me if I'm mistaken, because that kind of, you had a telescope and a microscope, and you gravitated towards a telescope. uh, what is the lesson here? Your parents, you got a bunch of things, and you somehow give your kids a bunch of things, hope that one, they stick to something and really thrive towards that. What is it? What was the message here,
Yeah, I
according to
mean,
you,
I
Priya?
think my parents kind of indulged me with a lot of different things, right? So, materially, it was the telescope and microscope that I often present as a contrast, right? So, I learned Carnatic music, I learned Bharatnatyam, no compromise. There was no question. I had to learn them, right? I even learned the
Mm,
piano briefly, but I complained about the piano teacher, so they said, "Okay, fine." She was smoking, and I could found it really annoying. I couldn't breathe, whatever. So I regret it now. Like I wish I had learned it, much more with more shraddha at
mhm,
that point. But I did. But I learned a lot of things, and my parents basically steered me. Anytime I said, "Oh, that looks very interesting," they'll say, "Okay, do you want to try that? Do you want to do that?" Do you want to learn? Then I would say, yeah, sure, I learn. And the thing is, the lessons that my generation has to offer is slightly different. Right now it's super easy to learn anything. You go to YouTube, you get a bunch of videos, you kind of, you're on your way. Or you go to Coursera, edX, or whatever. In our time, it was quite different. I mean, there was a different level of internal motivation that you needed to go find things. Information was not so easily available. So that took a lot of effort, right, to go find things. And so, and I think books were for me, also, as I said, right, that growing up, right, so we had the Encyclopedia Britannica from the year 1969. We had the full set in my house. And that set, that's a very special set, right? It's a set where the special relativity explanation is written by someone called A. Einstein, and the psychology of mind section is written by S. Freud. So they were kind of, it was dated, but my parents had that full set from their whatever journeys, their explorations. And so I would flip through and I would read. Yes, it was readily available, but I would read through things, I would try to learn, I would ask my parents, oh, how does this work, how does a gas turbine work, how does a windmill work, and so on and so forth. So I think that the having kind of now, I think there's absolutely no excuse for kids. I mean, they can learn anything they want. And I think parents just need to let them explore, not with the idea of necessarily finding them a passion or a profession or a track or anything, just letting them dream, and imagine. I think the possibility, having the possibility to dream that you could fly an airplane, or you could learn how planes work, or dream that you want to be, you want to drive a fire truck, right? Those possibilities, making those possibilities like happen in your mind. I think that's what's important. It's not so much, I think it's easier to get children to really have an explorer mindset, if you don't say, well, you're exploring with this purpose of helping you find a career in your life, or a job that'll make you money and let you live the life or whatever. I think there's a long period of time we should let our children just roam and find whatever they are interested in. And in this day and age, just encourage them to go learn. They say, okay, you want to learn, you want to learn French, go do it on YouTube, right? And there's fantastic resources. You want to learn how to take care of orchids, you love the orchids that somebody brought into your house, or you saw them somewhere, go learn that, right? You love bugs, go learn about tardigrades, right? I mean, I think right now, I mean, I have to admit that there are ways in which I feel, wow, it would be so amazing to be a child now, to just where access to
mhm.
information is no longer a hurdle. Don't you feel that, Sanjay, yourself, that
But also
it's
dangerous to be a child now too, with social media and everything else too.
it's actually it's
Yeah.
too much
So
also. There's too much
A
there.
pressure, especially
Overwhelming.
for young teenagers, the intense
Yeah,
pressure. But coming back to inflection points, you were privileged to have one of the early computers. Every kid, I presume, in India didn't have the Sinclair.
not at all.
And because of that, you could do the mapping of the stars in there. But you had the computer. A lot of kids get computers and don't do anything with it. What was it that about maps that that drew you? I mean, what is it about maps? I mean, generally not too many people are obsessed with maps or black holes or uh,
Yeah.
celestial things at such a uh, early age. Was it the Nehru Planetarium, or what was it that kind of got you going?
I think the thing that I loved about maps was the fact that they signaled what we know. Like it maps, I mean, it delineates what is known and what is not known, right? So a map kind of delineates like the state of knowledge, if you will, in a way. And what I used to love about old maps was that there would be, these old explorer maps, right? You would have, Vasco da Gama's journeys or Captain Cook's journeys, and they would be mapping out these parts of the world that they were discovering, right? And what I loved about those renditions of those maps was that there would be a piece that would say terra incognita. I have no idea what it is, right? So they know, they're constantly aware of the limits of their knowledge, and they are constantly, I mean, maps encode the limits. They give you knowledge, they map out a territory so you kind of get to know what it is, but then you also admit as part of the mapping that the things you don't know. So I think this kind of you know humility about not knowing there's more to explore, I find super motivating. And I think that's what got me started, because I was originally looking at historical maps of the earth, right, before I launched myself into the sky. So I think to this day, that is why I find maps very powerful. They are sort of fundamental way of knowing something in a very deep way. And when I'm doing sort of cartographic maps of dark matter, the goal is, we don't know most of the universe. 90% of the matter in the universe is this thing called dark matter. This is stuff that's not in the periodic table. It's not a known element anywhere. So we are not made of it, right? And the stuff that we are made of, it is just 4% of the matter inventory. Everything in the periodic table is just 4%. Rest is completely unknown. We believe it's a particle that was likely made in the very early universe, a dark matter particle, but we don't know its true nature. We have clues because the entire universe is shaped by, because it's a dominant component, its gravity shapes everything that we see in the visible universe. So the 4%, the illuminated 4 to 5%, is completely shaped by the unseen sort of 90 plus percent of matter. And the idea is, mapping now is that if you can map this distribution of dark matter, we know what it does because it exerts gravity, and it displays all the properties of gravitational matter. So it affects the motions of celestial bodies that emit light. So galaxies, stars, their motions are impacted by the presence of dark matter, and that's how we know there's dark matter. And gravity also bends light, so it distorts the nature of light that we receive from distant objects. So by looking at those distortions and knowing what the undistorted shapes look like, which we do, because the dark matter is not everywhere, it's clumped and
Hmm.
lumped in the universe. So there are certain lines of sight where there's not that much dark matter. So we know the undistorted shapes of distant galaxies. So then when we see a distorted field, we can use the baseline, which is the undistorted, and work out how much matter you need to distort it by this much. And that's how you map. That's the map of dark matter. So the goal for me has been, is there something we can derive about the true nature of dark matter by its spatial distribution? So, how densely clumped is it? And that carries a clue. So that's what people like me have been trying to do, and there are many others involved in this game. It's a big industry now. And the data, it used to be when I first entered the game, the methodologies were much more sophisticated than the data, right? Because there were all these people with me, like me, theoretical, computationally minded, who were coming up with new algorithms to understand this. But then the data got very quickly with the Hubble Space Telescope, the ground based telescopes, the data got so much better. And now we are at a new point where the LSST Rubin Observatory, which is going to map out the sky every 3 days. And they had a first release of images this June, exquisite data, almost as good as Hubble space data from the ground. It's a telescope in Chile. So now we are in this data deluge phase where now our methods need to get much more sophisticated. Mapping methods have to. So this
Mhm.
there's this kind of interplay for inference from maps that is just so
Mhm.
fundamental to a lot of many sciences. You talk about genomics, it's a map of the genome, right? So it's mapping is such a fundamental device for inference, for explanation, for scientific explanation, and it also carries within sort of the limits, like where we are at the moment and what we need to do better.
Mhm. Wow, I'm going to be looking at maps in a very different way from now on. But uh, Priya, there have been other inflection points, launch points, as you say, in your journey. Obviously getting to MIT, and then getting into Cambridge, then coming back into Yale. Is there a common thread, and what are the lessons there for our listeners? If you look at some of these big inflection points, and also you address something which is, I think, firstly, I really commend you on that, is that you had to deal with something, a big setback personally, but you overcame that. And because all of us have those kinds of situations. So, it's not like everything is up and up and up.
Absolutely.
So,
And you
yeah,
don't want to give young people the impression, right? They see me today, they're like, oh, you're on Time 100, you're,
yeah.
Carnegie's great, Americans great immigrants. There's a lot to that backstory before you get to where you are today. And, it may all seem effortless, as I mentioned today, even like the work and operating in all these domains and doing so much writing, reading, research, publication, etc. But you're absolutely right. The setbacks and the inflection points really critical, especially the setbacks.
So, what is for our listeners? Is there a common thread? You were brave enough to come. I would say, uh, very few people at that time were coming into MIT. Young women from India for astronomy,
Yeah,
uh, and then you went on to Cambridge, and then you came back to Yale, and then obviously, firstly, were your parents supportive of you coming to MIT?
absolutely. Absolutely. No question. And I think that's where I
Okay.
said, I won the birth lottery with my parents, specific set of parents. So, this is a time, like you can imagine, right? I was still a teenager. My
Hmm.
parents, my father, I was never brought up to think that as a girl in my family that I couldn't do something or this was out of
Hmm.
bounds or I didn't have the capacity. No. In fact, of my siblings, I'm the only person who actually came out to study. My brother studied in India. They chose to stay in India and they studied there. And my father understood that this was an incredible opportunity. But you know how it is with parents, right? My parents, I lost my father 2 years ago, and that's been a pretty tough blow, especially when all of these amazing, unanticipated accolades are coming, and he wasn't really around for them. But my mom is still around, and I think that it's the kind of, they had this incredible belief in my capacities, clearly. And it was not, it was not like they thought I could do, I could do anything and everything. But my parents, like, you put your mind to it and you make the effort, Priya, you can do anything and everything. It wasn't like, oh, everything will come to you. No. They were like, you can conquer anything, but you have to put your mind to it, focus on it, and put in the hard work. And then, any dream is yours, and no dream is beyond reach. And I think having that as a mantra and as a source of support, right, even in the down times, made a huge difference. It made a huge difference. And then, of course, I did have mentors. Of course, I had, important mentors at very critical times. At MIT, I had I know it's going to sound like name dropping, but Sanjay, that's my life. Okay, that's so. There's an incredible physicist named as Alan Guth. He made a huge discovery that our universe is expanding exponentially very early on in the universe, not now, inflationary universe. So he was a strong mentor. I started working with him, and he was very supportive. And I had another professor in history and philosophy of science, Evelyn Fox Keller, who's sadly no more. These people have actually stayed with me, right? They're still friends. They, every step of the way they're there sort of cheering me on. So I've had people like that. And similarly in Cambridge, I had my tutor at college. I had my PhD advisor. There are people I worked with, right? And they were all real cheerleaders who, they were at a time when you are slowly kind of making it in a profession and finding your feet in the career. I always had these people who believed I had more capacities than I personally believed in. I
Hmm.
always thought, can I really do this? Am I capable? Can I hack this? And I would have moments of self doubt. Obviously, you are when, especially when you're very young and you're like, you don't know whether is this going to work out? Is this not? I mean, did I make a good decision by moving to the UK to do this PhD and so on? I think that there, the fact that I had these people around me, of course, my immediate family, and these mentors, very accomplished people professionally, and that's where the luck comes in, right? I went from one kind of intellectual mecca to another intellectual mecca, where this kind of tradition of apprenticeship and bringing up young minds is part and parcel of the academic culture everywhere, here and in the UK, right? I ended up in these environments where it is about, for a lot of us, and I'm now inverted in the role, it is about nurturing young, bright people, helping them find their capacities, right? That's what people like me do now for younger people. And I'm sort of paying it back for what people did for me. And I had a lot of that lineup, and then I had inspiration, right? So, inadvertently, I was following the footsteps of Subramaniam Chandrasekhar, right? He also went to Trinity. He also became a fellow. He also worked on black holes. He also faced a little bit of intellectual backlash with his ideas. They were a little bit ahead of time. I had that same experience for a few years till these direct collapse black holes were discovered by James Webb Space Telescope. There's this idea that you could make black holes a bunch of different ways that people thought was too radical, right? And it turns out that now we are finding all these black holes that don't look like they could have been made the traditional way, which is the end point of the life of a star, right? That they need to have been made in different ways. So I think that, I had role models on the ground. I had these inspiring people that I, wasn't consciously looking up to or emulating them in any way, but that I would just feel so grateful, right? So I was at Trinity College, and when I got elected to the fellowship, I was the first woman in astrophysics ever, right? This college has been around since the 1600s. So the first woman. It's kind of late, but whatever. I was the first woman. And I remember at the induction, I signed in this notebook where the first page was signed by Isaac Newton. And a few pages before me was, 40 pages before me was signed by Subramaniam Chandrasekhar, right? So I looked through those and I was like, oh, wow. Okay, now I really have to take this seriously. I'm being given this enormous, conferred this honor, privilege, and responsibility, right? That I have to do something that with my mind, and I have to push myself to do something quite incredible, right? It's motivation. And I never felt stressed or overwhelmed by it or whatever. I just felt inspired. And I said, I don't know whether I can do this. I'll try my best. And but I think also I think that many of us, our generation, when we grew up in India, I think humility and gratefulness were very much part of our being. Anything and everything that I got from a young age, so grateful, so grateful. And I was taught that. I was taught that no matter what you have done, your own contribution is. You have to be grateful for the way things work out, because not everything is in your control. Not everything is about you, and it's a lot of external circumstances working out, right? So I think sort of this kind of cocktail of mentors, role models, inspirers, and being grounded always and feeling that, oh my God, I'm so grateful to be here. And I have this enormous opportunity that so many other people can dream of, but did not have this fulfillment, couldn't do it, and didn't get this opportunity. And so I have to make the best of it. And I have to, but I also have to fork and find my own path. I have to forge my own path. And I wasn't particularly motivated by careerism, and that really helped too. In the sense, I didn't feel that, oh, I have to get this thing or that accolade next, or I have to get that promotion or that thing. Wasn't as fixated on those things. And at times, my own colleagues would tell me, it might be useful for you to be a little more careerist. But I didn't. And for example, in my field as well, right, I work on these two big open problems: black holes and dark matter. Most people would have chosen, the way the field works is about specialization, right? So you would have chosen one or the other. My own advisor told me, Priya, it's really risky. You're working on these two big open problems. The problem is the way the field is. Whatever contributions you make, right? Because you won't be drumming up that one tree about what you did, that there's a chance that people will dilute your contributions. So there's that risk, right? And I said, no, but I love these two problems. They are both challenging in very different ways, and I'm going to do it. And so he said, okay, that's a tighter path, especially in America. And I think he was right. The grant funding agencies have a mode, and that is, you're the world's expert in that one little thing. You're not like a broad sort of scientist, right? Just scientific style. That's the style of Cambridge, England. Physics style of Cambridge is that you have mastery, but you're broad kind of mastery, and interest in application and translation. So yeah, so I think there were lots of factors in those inflection points that kind of coalesced and kind of aligned somehow.
No, that's true. And I think you point out, as a lot of our guests talk about, the role of mentors who come in all shapes and sizes, can be parents, family, teachers, colleagues, etc., that have played a key role. Uh,
But I also
we
learned
should
from detractors. I also learned
detractors
a
too.
lot from my competitors, right? My competitors who
Okay.
were ruthless competitors, right?
Well,
And one
in academics also you have competitors. Wow.
Oh my God. Oh my God. And the stakes, you know what? It's not about money. Remember, there's no money
Yeah.
in astrophysics to be made. Nobody is becoming rich. It's
Yeah.
all about ego, fame, and reputation, right? I mean, who you did what first? Did you do something first, right? Everyone's kind of pushing for that kind of discovery and breakthrough and recognition, right?
Yeah.
So, I learned a lot though from those people, right? I mean, one of the first things that I learned, and I think
Mhm.
this is where I think it's my own temperament that comes into play, right? At the end of the day, our personal temperament is important, and it's a fundamental part of everything we do. I did not want to be changed by the culture of the discipline. I wanted to continue to be me. The culture of academic culture of physics is, at least when I was coming up, it's improved now, it's very macho, and it was all about who's the smartest person in the room, the pecking order, obsession with the pecking order, who's smart. And of course it was very male, right? And I think that in a way, not belonging was a plus for me, because I was able to be myself. So a, I was a young woman with a lot of interests. I love style, I love fashion, I mean, I love all kinds of things, right? And I didn't feel like I had to be boxed into, looking like Einstein with unkempt hair in order to be, recognized for my originality or whatever, right? I mean, I was like, I don't care. I'm just going to be me. And it's harder. It's easier to learn and mimic the way in which the field works, the way in which, in my case, the men in that field operate very aggressive interchanges at conferences, at seminars, calling people out and showing how smart you are, that kind of performative academic what can I say, showmanship. I did not buy into it ever. It was not my thing. It's not my nature. And, by nature, I am not aggressive at all. I'm assertive. So when I know something, I know something, and I'm very happily ready to admit I don't understand something. So even when I give talks, I say, okay, here are things I really understand well, and here are things I actually do not understand and I want to learn more. And I'm happy admitting that. I don't have an ego from a very young age. I never felt that. And that is the advice I got from some of my mentors. They said, you know what, you have to know what you know really well, but then be willing to admit that you don't know a lot of things. But that's what academia is about anyway, right? We are constantly learning.
Well, that's true. Know what you know very well, rest, admit you don't know. Priya, at the end, everybody, this is for our listeners who maybe not into astrophysics, maybe can't get into an MIT, can't get into a Yale or a Cambridge, but they probably have different passions and different capabilities. What would be a message to some of those people? Because you are breathing rarefied air in some cases too, right?
Yeah, yeah. No, and I think obviously, these places have a cachet for a reason. They have ample resources and, support for I think, ultimately it really doesn't matter if you are able to learn and satisfy your curiosity, build expertise in whatever you do. And as I said, as long as your focus is mastery, and I know it may sound cliched to Indians, but there is an enormous amount of truth in the Bhagavad Gita saying that karma neva adhikaraste ma phaleshu kadachan, right? That there is something about dedicating yourself to understanding or building expertise, whatever you do. If you are someone who is at home, who is only cooking right now and taking care of cooking responsibilities for your family, right? Doesn't matter. It's about doing that really well, and learning, and as I said, mastery, just mastery in whatever you want to do. I think there's a sense of fulfillment that you get and contentment that you get from mastery that I honestly believe, of course, I have not experienced this, that no amount of money can give you. I obviously have not experienced that, but my sense is the kind of joy and the kind of contentment and fulfillment that you can get out of doing any task really well and mastering it. And, working any job. I mean, I think there are ways in which any job and every job can be fulfilling, and it really depends on how you approach that job. And you don't have to feel stuck in anything that you do, because there is a way to refresh and look at a different facet of what you're doing. Or if you don't like what you're doing, there's a way to learn yourself out of it. You can go learn more and move. And I think today's society, that's one of the big advantages. This notion that you'll have one career in your life has completely gone, right? I mean, I think it ended with my generation, basically. Now, if you look at any person who is accomplished, younger person, right, they've done lots of different things already, and they will continue to do different things in their life. So one is never stuck. And I think having that mindset, I think it's more than just the growth mindset. I think it's this exploration and curiosity driven life mindset. It's not just about knowledge. It's about, just knowing more about the world that you live in and understanding the world, understanding people. And that gives you a lot of fulfillment and contentment. I find that contentment is something that a lot more people need to aspire to, um, and that is something, I mean, it's a struggle in this world that we live in, which is so competitive. It's always about next success, next thing, next thing. It's hard to understand that you savor something when you get it. And that is also invaluable advice that, my mother gave me from a very young age. She said, you have to savor everything. If you figured out how to dig out a plant and get its roots intact, and something, I did a lot of gardening help with her. She said, you've got to enjoy that. You didn't kill the plant. You have that, you savor that. And I think that's come in handy now, right? With otherwise you can get on this kind of hamster wheel, as you know, professionally, where you can keep wanting the next thing and the next thing.
Yeah, that's a good advice. So basically, I think what you're saying is get mastery done and also keep exploring, keep changing, and then savor the moment, savor what you have achieved because we are constantly looking forward and we really don't have that sense of contentment. So, fantastic advice. Priya, at the end, we do have a lightning round of some quick questions that we want to ask.
Hmm.
So, you ready?
Yep.
Okay. What is your definition of Indianness? We ask this of everybody because everybody has a different definition.
I think my definition of Indianness is respect for our culture and our heritage, and a desire to know more about it and learn more about it.
Respect culture, heritage, and want to know more about it. That's pretty cool.
Constantly explore
Uh,
it, because we have such a deep culture, such a deep
mhm,
heritage, which is so sophisticated, so nuanced in so many
mhm,
fields, that at least I find still, right, every time I go to India, I grew up there, right, partly, I still
mhm.
feel I discover something about India every time I go.
Yeah, that is so true. They say you can leave India, but India will not leave you. Uh, Priya, who's been the most influential person in your journey? One person.
I would have to
Can be in
say,
your family. Yeah, go ahead.
well, oh, you mean one person that I pick? I mean, I
Yeah,
have to pick two. I will have to pick two. I mean,
I
I'll
know
pick
who those
my
two are.
mom and Dr. Nirupama Raghavan, right? I mean,
Okay,
I think without,
okay.
um, see, I would have picked three, but I stopped at two. Obviously, my dad too, but
Oh, that makes it three.
I know, I know.
Okay, we'll give you that exception. This is something I've been wanting to ask you: is do you believe that there is life outside of this earth?
Absolutely. I mean, the possibility exists. There's no reason why not. And I think the
Mm,
only thing we have to be cautious about is that, it may not be life the way we recognize it, because we know the accident of life on Earth, right? And I think Stephen Jay
mhm,
Gould put it very nicely. He said, if you run back the tape of evolution on our own planet and then rerun it, because randomness makes such a big difference, you will not end up with beings that look like us, right? So there's no need to expect that it'll be carbon based or look like us or whatever. But sure,
mhm.
I mean, there's so many other planetary, exoplanetary systems that it would be odd if there was no other life.
Okay. Let me ask you a little harder one. MIT or Cambridge?
Ooh, that's a hard one.
Mm, I
Um,
knew.
MIT, probably, because it
Uh,
shaped me.
okay.
Shaped me. It's home.
Okay.
It's home.
Okay. Columbus or modern?
None of the above. DBS.
I knew DPS, of course. Okay. Theory or observation?
That's a hard one for me, because
Hmm.
I pride myself as a person who's an interlocutor, who does, connects the two,
Hmm. Of
and
course.
that, yeah. Love is probably theory.
Okay. Black holes or dark matter?
Really hard one.
That,
There's a
that's
new
the whole
theory that
point.
suggests that all dark matter may be black holes. So I could actually technically say both because of that.
Okay. Uh, Priya, do you believe in luck?
I do.
Do you think luck has played a role in your journey?
Absolutely. I mean, when I'm talking about, these inflection points, right?
Yep. Yep.
It is being at the right place at the right time with the right temperament, of course. Another person who
Mm-hmm.
had the same opportunities may or may not have turned out the same way, right? I mean,
Mm-hmm.
but luck, of course, it plays a really important role. I'm super
Awesome.
grateful for that, right? And
Yeah. And we are super grateful to have you. It's been absolutely fascinating listening to you. Your work reminds us that we're all kind of made of the same star stuff, connected to the cosmos in the most fundamental ways. And thank you for making us understand our place in this vast, mysterious, and beautiful universe. And thank you for the journey you had and the lessons for all of us. Thank you for being on this podcast. There's still a lot more to learn about your journey, but that'll have to be in part two and maybe part three because there's still many journeys to come ahead of you. We didn't even talk about where you go from here, but that'll be part two or part three. So thank you for being on the podcast
yeah,
today.
thank you so much, Sanjay ji, for inviting me.